Hey guys, this is topic 5.4 about equivalent fractions. You're going to need your notes and your pencil. Our objective, what we're trying to do today, is to write equivalent fractions. So it's topic 5.4, so you're going to use your Roman numeral 4, equivalent fractions. And we just need to remember the word equivalent means equal. So we're going to be writing equal fractions. Before this will work though, you need to review the identity property so you'll understand why we're doing what we're doing. Remember, the identity property, multiplication and division, said that if you multiply or divide any number by 1, the number stays the same. Like 5 times 1 is a 5. Even though I've multiplied it by something, it stayed the same. 8 divided by 1 equals 8. Even though I divided it by a 1, it stayed the same. Now, keeping that in mind, that if you multiply or divide something by 1, they stay the same, but you need to also remember what fractions really are. Fractions are really unfinished division problems. That bar right there really means divide. 6 really means 6 divided by 6. And how much is 6 divided by 6? It's 1. And 5 over 5, or 5/5, or 5 divided by 5, also equals 1. 3/3 equals 1. 10 over 10, that equals 1, because it's 10 divided by 10. So keeping these things in mind, our identity property, and that fractions that have the same numerator and denominator all equal 1, we can make some equivalent fractions. We're going to make some equal fractions. So I have my fraction right here, 2 over 3, and I'm going to multiply it by 1. And when I multiply it by 1, it is equivalent. It stayed the same. So that means if I multiply any fraction by 1, it should stay the same. So if I take the fraction 2/3 and I multiply it by another fraction, 2 over 2, remember this really is a invisible hiding 1, I should get an equivalent fraction. So you're going to multiply it straight across. 2 times 2 is 4, and 3 times 2 is 6. I'm saying that 2/3 and 4/6 are equivalent, or they're the same thing. So I'm going to show you visually. I've broken this bar into thirds because my denominator says 3, so I had to break it into 3 pieces. I'm going to shade in the numerator, or 2 pieces of it. I'm going to shade in 2 of them. And I'm saying that 4/6 is the same size. Even though it's have different numerals, it's the same amount. It's equivalent. So I broke this into 6 pieces because that's what the denominator said. I'm going to shade in 4. Look, it's equivalent. It's the same size. This is also true if I did it again. If I took 2/3 and I multiplied it by the equivalent, multiplied it by the fraction of 3 over 3, which is really just a 1. When I multiply straight across, I'm going to get 6/9. So I'm going to show you here. I have this one. I've broken it into 9 pieces. I'm going to shade in 6 of them. 1, 2, 3, 4, 5, 6. Look, they all have the same amount shaded in. 2/3, 4/6, and 6/9 are all equivalent. They're the same size. The same is true with division here. I have the fraction 16/20, and I'm going to divide it by 4/4, or divide it by 1. 16 divided by 4 is 4, and 20 divided by 4 is 5. I'm saying that 16/20 and 4/5 are equivalent, that they're the same size. So again, I've taken my bar, I've broken it into 20 pieces. I'm going to shade in 16 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this one says 4/5, so I have a bar broken into 5 pieces. I'm going to shade in 4 of them. 1, 2, 3, 4. It's the same size. So let's try it again. I have 16/20. I'm going to divide it by the fraction 2 over 2, which is really just a 1. 16 divided by 2 is 8, and 20 divided by 2 is 10. I'm saying that 16/20 and 8/10 are equivalent. So here I have my bar. I've broken it into 10 pieces because that's the denominator. I'm going to shade in 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. They're all the same size. I'm saying that 16/20, 4/5, and 8/10 are all equivalent. They're all the same size. Okay, that's it.